have a good memory. All right, here we go. The normal, okay, as I mentioned, it's important because we see it in many physical, scientific, and psychological type of variables, okay? So let's just take a look at the following list of marks for Dewey, Mr. Dewey's ESL class. Oh, okay. So here are his marks. Some are low, some are high. Ooh, look at that 38. Oh dear. Okay, to prepare a frequency polygon, we must determine appropriate intervals. Do you remember we took the maximum, we might subtracted the minimum to find the range of our variables? We need 6 or 7 intervals, approximately 10 units each, so it seems to fall nicely if we go 30 to 39, 40 to 49, etc., etc. Here's the frequency, here's the relative frequency, and this is a relative frequency polygon, okay? Now, notice that this is has approximately a bell shape, something like that, right? That it's approaching a normal distribution, a bell shape. Notice that the shape of the frequency polygon roughly approximates a bell or normal distribution. So let's find out some characteristics about the normal distribution, okay? Now, we have a picture of it on the other side, and I'm going to be flipping back and forth. I hope that doesn't make you dizzy here because I'll be flipping. The normal curve has the following properties. It is symmetrical. The mean, median, and mode are all the same value and fall on the line of symmetry. So let's look at that nice picture of the normal distribution on the other side. So notice, this is the distribution, this is the mean, and the mean, median, median, and mode all fall on the same spot. Okay, this is a perfectly normal distribution where the mean is here, the median is here. That means 50% of the data are below the median, 50% are above, and the mode is here. The most frequently occurring value is here, right? Let's look at point number 2, and I mentioned it already. The area under the curve equals 1 with 50% of the data below the mean and 50% of the data above the mean. So notice what the area under the curve means, like this area under the curve. One day when you study calculus and integration, you'll be able to find areas under the curve. So that's a little bit ahead of you right now. But just know that 50% of the data are below the mean and 50% of the data are above the mean. Okay? Because this is the median, and the median cuts your data in half, so 50% are below, 50% are above. Let's look at the next point. Approximately 68% of the data is within 1 standard deviation of the mean. Now let's take a look. Approximately 68% of the data is within 1 standard deviation of the mean. So notice, this is the mean minus 1 standard deviation. There's the mean plus 1 standard deviation. So this is within 1 standard deviation of the mean, approximately 68.27%, or the area under this portion of the curve right here, 68.27% fall there. Okay? So we could say that if we were to cut that in half, we would get 4.135% fall there, and 4.135% fall there, for a total of 68.27%, right? 50-50. It's all symmetrical. Now, 95.45% of the data, they're saying approximately 95% of the data, this is a little bit more accurate, 95.45% of the data fall within 2 standard deviations of the mean. So from there to there, we have 95.45% of the data. Does anyone care to tell me how much falls there and how much falls there? We're going to need a calculator, right? Because we're going to have to take the total minus this and divide it by 2. So if we were to take 95.45 minus 68.27, that's equal to that. And I'm going to divide that by 2. I'm going to change it to decimal. I'm going to divide it by 2. So I get 1.359 or 13.59%, right? And 13.59% fall there. Does everybody see how I got that? Okay. All right. Well, let's see what we can do between 3 standard deviations of the mean. So we have mean minus 3 standard deviations all the way up to mean plus 3 standard deviations. You have 99.73% of the data fall. So if we were to find the probabilities in each of those sections, let's just see. We're just going to have to go 99.73 minus 95.45, and that I'm going to convert that to decimal, divide it by 2. So, I like my decimals. This is 2.14% of the data fall, 2.14% of the data fall. Now, what falls below this? Well, let's see. We're going to have to go 100 minus 99.73 and divide it by 2 and convert it to a decimal. So about 0.135% fall below here. So it's going to be 0.135% and 0.135%. So if you were to add all these up, the 0.135, 2.14, if you add all these up all the way up to 2.14 that should add up to 100%. Okay? In every normal distribution, everyone, regardless of the population, whether you're talking about GDP per capita for the world or average height of students at York, for all the students at York Mills, the standard deviation always divides the population into the same regions representing the same percentages. And as you get more experience with your calculations, I'm going to keep pointing that out. So if the average height of students is, say, I don't know, 1.6 meters, I don't know, and the standard deviation is 0.25 of a meter, then if I were to go 1.6 minus 2.25, what is that? That is 1.35 to plus 0.25 is going to be 1.85. I can say that 68.27% of the students have a height between 1.35 and 1.85. Right? Okay, and we'll get into that. The area under the normal distribution between any 2 data values represents the probability that a data value picked at random is between 2 given values. The few let's do an example. The fuel economy of today's vehicles tends to be normally distributed. The data below shows the approximate city fuel economy of 50 new vehicles. Okay, so what we need is we're going to first calculate the mean fuel economy, and then we're going to calculate the standard deviation. We're going to need that before we can start applying the normal distribution to this, okay? We need to know standard deviation, right? Because the normal bell curve is divided by standard deviation. So let's calculate the mean. X bar equals sum of xi fi all over the sum of fi. So this is going to be 2 times 18 plus 8 times 2 plus 14 times 26 plus 16 times 30 plus 9 times 34 plus 1 times 38 all over 50. The sum of Fi is equal to 50. So this is divided by 50, and we get 28 liters per 100 kilometers. So the average fuel economy of today's vehicles is it takes 28 liters to drive 100 kilometers. It seems like a lot of liters. This must be not very fuel efficient. Just seems like a lot. Okay, let's calculate the standard deviation. Is the sum of xi minus xi squared fi all over the sum of fi minus 1. Okay? Okay, so let's do it. 18 minus 28 is negative 10, right? 18 minus 28 is negative 10. Negative 10 squared is 100, so it's going to be 100 times 2 plus 22 minus 28 is negative 22, negative 6. Negative 6 squared is 36, so we're going to have 8 times 36 plus, let's see, 26 minus 28 is negative 2. Negative 2 squared is 4, so it's going to be 14 times 4 plus 30 minus 28 is 2, so 2 squared is 4, so it's going to be 16 times 4 plus 38 minus 28 is 6. 6 times 6 is 36, so it's 9 times 36 plus, that'll be 38 minus 28 is 10. 10 squared is 100, so it's 1 times 100 all over the sum of Fi, which is 50 minus 1. And if we were to calculate the standard deviation, let me fix this a little bit. S is equal to approximately 4.6. Yes? Yes. Thank you. Xi minus x bar. Thank you. There? Thank you very much. Yes. So it's x bar. We don't need the I there for x bar. It's just the average of all of them. Okay, good. Okay, so far so good. We have the mean, we have the standard deviation. Now we're get ready to go to set up our diagram. Okay. Okay, sketch and label a normal curve that could be used to represent this data. Round the mean to the nearest whole number and round the standard deviation to the nearest tenth. I think I'm going to get a pen. I just feel a little bit more comfortable. So let's do a bell curve here. Okay, so this is our mean. Our mean was 28, agreed? So right at the inflection point where it's curved down and then it curves up, that's where our first standard deviation is. So we go 28 minus 4.6 is 23.4, and this is 28 plus 4.6 is 32.6. And this is liters per 100 km. And you know from our previous calculations, 34.135% fall there, 34.135% fall there. Right? Now we're going to go within 2 standard deviations of the mean. So we have to go 28 minus 4.6 minus 4.6 again is 18.8. 32 plus 4.6, 32.6 plus 4.6 is 37.2. And just by our previous calculations, this is 13.59, 13.59. Now we're going to go up another standard deviation and down another standard deviation. 18.4 minus 4.6 is 14.2. 37.2 plus 4.6 is 41.8. And so here we had 2.14. And here we had, I believe, 0.135. And similarly on this side, 0.135. And this is 2.14. What is the probability that a randomly selected new vehicle will have a city fuel economy of 34.4 liters or better? So the smaller this value, the better, right? The fewer liters you use, the better, right? The fewer liters used, the better, right? The better it is, the better fuel economy. The better the fuel economy. Okay, so that's just that's so you know we want the probability x is less than 23.4. Well, that means if we want the probability it's less than 23.4, we want this total here, right in here, right? That's what we want. We want that total right in there. So the probability that the fuel economy is less than 23.4 liters per 100 kilometers is 13.59 plus 2.14 plus 0.135. And that is equal to 15.865%. So there is a 15.9% chance, basically, that the fuel economy will be better than 23.4. Well, what if it's 37 or better? So we want the probability x is less than 37.2. And just remember that whether we say less than or equal to, it doesn't matter, because the area under a single point is 0. Okay, so whether we say less than or equal to, the value will be the same. So now we're going to have to go 0.5 is equal to 0.5 plus 32.6. Oh, sorry, I'm adding the wrong number. I'm not adding the probabilities. going to be 0.5. Now to get up to 37.2, we're going to have to add on the 34.135 plus the 13.59. Does anyone see how another way we could have found this area here? Yeah, exactly. Right? We could have went 1 minus these two. So that is also equal to 1 minus 1 minus, that would have to be 0.0214 minus 0.00135, and that should give us 0.97725, or about 97.7%. I would like to check that, because I'm a checker. I'm always double checking. 1 minus 0.0214 minus 0.00135 and 0.97725. What is the probability that a randomly selected new vehicle will have a city fuel economy between 23.4 liters and 32.6? Well, okay. So now we're going to have to go from here to here. Oh, that's easy, right? The probability 23.4 is less than x is less than 32.6 is equal to 34.135 plus 34.135, and that is 68.27%. The notation: x varies normally with the mean is 75. The variance is 25, right? But the standard deviation is 5, is read. X is distributed normally with the mean is 75 and a variance of 5 squared. But don't forget, the standard deviation equals the square root of 5 squared, which is 5. In order to determine probabilities, it is necessary to calculate areas under the curves. And that's what we've been doing. Okay? Now, notice just a few pages ahead. See, we're not going to be, this was just for teaching purposes, because I want you to get a feel for the normal distribution. Notice a few pages ahead, we have the normal, the areas under the curve, the normal curve. Here are the areas under the curve, okay? And all these areas are summarized for you, okay? So you need to start memorizing this table for your next test. Jokes. I'll provide you with the table. You guys look so scared. You don't have to memorize it. I'll give you a table. Don't worry. Could you imagine? Don't worry. There'll be a freshly photocopied table for you. Okay. Let's show you. I want to show you how to use the table. Okay. Now, the table is set up for a mean of 0 and a standard deviation of 1. Okay, so remember, this is mean equals 0. The variance equals 1, but the standard deviation is the square root of 1, which is 1. Okay, so this is the way we designate that. That's the variance, and you just take the square root of that to find the standard deviation. This is the areas under the curves have been tabulated for this distribution where the mean is 0 and the standard deviation is 1. So if x varies normally with the mean is 0, variance of 1, find the following probabilities using the table of values under the normal curve. Okay, let's look at this. If our mean is 0, it is here. Agreed? So that means 1 is on this side, and we need this area. This area here. So we want the probability x is less than 1. Okay, this, and I want you to write this like this, okay? Some people just want to write the answer. They don't want to write the leading statement, okay? So let's go to our table. Okay, here is our, actually we call them Z value, and we'll talk more about that in a few minutes. But here is the Z value of 1. Notice this gives areas to the left. So the probability of the area of a Z value being less than 1 is 0.8413. Okay? So 0.10 is 0.100 is 0.8413. Okay, let's do this. So this is equal to 0.8413. Let's do B. What is the probability? Well, let's draw a diagram, and I'm going to have 3 questions on the test where you have to draw the diagram, okay? If this is 0, right, your mean here is 0, 1.5 is over here. We want this area. This is the area of interest. The problem is the table gives us areas to the left. Remember, table gives us areas to the left, not to the right. So how can we do this? So we're going to write down here, okay? The probability x is greater than 1.5 is equal to what? What is that equal to? Well, the total area is 1, right? Because probabilities add up to 1. And then we're going to subtract the area to the left, and that will leave us with the area to the right. So let's look up 1. What is the area to the left of 1.5? Can anyone tell me? Look at that. 1 point, sorry? Right, 0.9332. Thank you very much. So this is 1 minus 0.9332, and that's equal to 0.0668. Good? Uh-oh. Now they want the probability between 2 numbers. So if this is 0, then this is negative 1, this is 1.5. We want this probability. Okay. Remember, table gives areas to the left. Table gives areas to the left. All right, so how are we going to do that? How are we going to find this area? Okay, so probability negative 1 is less than x is less than 1.5 is equal to the probability x is less than 1.5 minus the probability x is less than negative 1. So now we have to look up 2 values. Well, we looked up 1.5, and that was 0.9332 minus the probability it's less than negative 1. For negative values, we have to go on this. See how there's negative Z values here. So negative 1 is 0.1587. And that's equal to 0.7745. I'm going to add a few more questions for you. What's the probability x is less than 2.45? See here, we've only been dealing with one decimal place. What if it's less than 2.45? Well, we have that. 2.4 is there. And now we have to go under the 0.05 column and read down here. So I get, what did you guys get? Do you see what I've done? 2.45, we get the second decimal place from the column. So that's 0.9929, right? Okay. Well, this one, these I want to, x is less than negative 5.7. Let's look at our table. Notice the smallest number it is goes to is negative 2.99. The probability x is less than negative 2.99 is equal to 0.0014. What do you think the probability x is less than negative 5.7 is equal to? Huh? If this is close to 0, then we approximate this with 0. So we'll just say approximately 0. F. What about the probability x is less than 5.7? Now let's see. Notice the probability x is less than 0.9986. Sorry. The probability x is less than 2.99 is equal to 0.9986. So the probability x is less than 5.7 would be equal to approximately 1, right? Since this is close to 1, then this is even closer to 1, right? So we approximate it with 1. Now, what if we want g, probability x is greater than 5.7? What do you think that would be? It would be 0. I mean, if that's close to 1, yeah, it'd be 0. Can I explain anything better? Anything at all? So I'm going to stop right there.